Types of sets. Types of sets are empty set, finite set, infinite sets, equal sets, equivalent sets, subsets, power sets, and universal set. Let us see empty sets first. So, empty sets, a set which does not contain any element, which does not contain any element is called empty set, is called empty set. Or null set, or void set, Let us see set P x such that x is greater than 1 and less than 2. X is greater than 1 and less than 2. X is a natural number. X is a natural number. X is a natural number. So, in this, you see, x is a natural number. Is there any natural number lying between 1 and 2? Your answer will be no. Then obviously, therefore, this implies P is a set having no element. This is represented by this. There is no element in this curly bracket. This can be represented by the Greek letter phi also. Alright, the same this symbol is for void set or null set, this also is for void set or null set. Let us see another example, that is set Q. So, set Q, let it be x such that x square minus 2 equal to 0 and x is a rational number and x is a rational number. X should be a rational number. See, the meaning of x square minus 2 equal to 0, it means that x square is equal to 2. It means x is equal to square root of 2. X is equal to a square root of 2. It means a square root of 2 cannot be a rational number. A square root of 2 cannot be a rational number. Therefore, this is an empty set. This is an empty set. Only reason is that x is equal to, because x is equal to a square root of 2, which is not a rational number. A rational number नहीं है. That is why this is an empty set. Let us see finite set. A set which is empty or consists of. A set which is empty or consists of a definite number of elements. Definite number of elements is called finite sets. So, it is countable. A countable भी होता है, countable, and can be written in roster form. Can be written in roster form. In roster form. This can be written in roster form. For example, let A be a set. Let A be a set having its element A, E, I, O, U. These are the elements. Let us see another set which is B set having its elements 3, 5, 7, 9. Let it be 3, 5, 7, 9. These are the elements. So, the set A and set B are countable and is in roster form. So, set which is empty, the empty set also will be considered as finite set. Let us see infinite sets, a set that is not finite, a set that is not finite, and elements of the set are and elements of the set are endless or uncountable elements are uncountable, endless, and cannot be written in the roster form and cannot be written in the roster form. In the roster form में इसको नहीं लिख सकते हैं. Such as example, natural number. N is the set of natural numbers. ये क्या है? Set of natural number. Natural number का set. Another example is, this is infinite. So another example is Q plus, means set of positive rational number. Q plus set of positive rational number. Set of positive rational number. Another example you can take like Z plus, set of positive integer. This is set of positive integer. Like that, there may be a lot of examples. Alright, now equal sets. Equal sets. Two sets are said to be equal. Two sets are said to be equal. Two sets are said to be equal if they have exactly the same element. If they have exactly the same element. Same elements, you can say. So let us see the example like set A. Like set A having elements 3, 4, 5, 7. 3, 4, 5, 7. Let us see another set B having its elements 5, 7, 3, 4. 5, 7, 3, 4. Let it be 4. 5, 7, 3, 4. So, set A having same element, see 3, 4, 5, 7 is, and see set B 3, 4, 5, 7. Position, change of position doesn't matter. It means what? Set A is equal to set B. This implies set A is equal set to set B. Set B and set A are equal. Let us see equivalent sets. equivalent sets. Two sets A and B are said to be equivalents. Two sets A and B. A and B are said to be equivalent. Said to be equivalent. Equivalent. Two sets A and B are said to be equivalent if they have the same number of elements. Have the same number of elements. Same number of elements. It means cardinality of set A is equal to cardinality of set B. It means cardinal number of set A is equal to cardinal number of set B. Let us see the example like set A having elements A, E, I, U, I, U. Set A having elements A, E, I, O, U. All right. 1, 2, 3, 4, 5 elements are there. And let us see, say set B having elements 3, 4, 5, 6, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5 elements. So cardinal number of set A, it means cardinal number of set A is equal to 5 and cardinal number of set B also is 5. Therefore, set A is equivalent to set B. Equivalent set. Let us see now subsets. Every element of set A, every element of set A, element of set A, every element of set A is also an element, is also an element of set B. Every element of set A is also an element of set B. Then A is called subset of B. Then A is called subset of B. A is called subset of B, or A is contained in B, or we can say A is contained. A is contained in B. A is contained in B means A is, therefore A is subset of B. It is if at least one element of A does not belong to B, one element of set A does not belong to B, then A is not a subset of B. Then A is not a subset of B. Subset of B means this implies A is, we can write symbolically like this, A is not a subset of B. It is possible that every element of A, element of set A is in B. It is possible. And every element of B is in A. All right. Then A is subset of B. Then A is subset of B and B is subset of A. B is subset of B is subset of A. A is subset of B and B is subset of A, because every element of set A is in B and every element of set B is in A. It means, or this implies, set A is equal to set B. This implies set A and set B are equal set. Let us see example. Let A is the set. Let A is the set having elements 1, 3, 5. Having elements 1, 3, 5. And B is the set. And B is the set X such that X is an odd natural number. An odd natural number. Odd natural number less than 6. Less than 6. Odd natural number less than 6. It can be only 1, 3 and 5. It can be 1, 3 and 5. It means set A is subset of B. This implies set A is subset of B and set B is subset of A. Reason is very clear. This implies A is equal to B. A is equal to B. Another example you can take. Another example like P set. P set having element A, E, I, O, U. And Q set having element B, C, D and E. Alright. So P is not a subset of Q. This implies P is not a subset of Q. And Q is not a subset of P. Q is not a subset of P. After that, I am going to explain you power set. Power set, the collection of all subset of a set A, the collection of all subset of all subset of A, of set A, all subsets of set A is called power set of A. Is called power set of A. Set of A. That is, in power set of A, every element is a set. Every element is a set. If A is a set having its element 1, 2, then power set of A is equal to set, empty set phi, set 1, set 2, set 1, 2, set 1, 2, 1, 2, 3, 4 means cardinality of power set of A is 4. 4 in the sense 2 square. 4 in the sense 2 square. It means that power set of cardinal number of power set of A, cardinal number of power set of A is equal to 2 square. 2 square, that is 4. In general, you can say if A is a set, if A is a set with cardinal number of set A is equal to M. Cardinal number of set A is M, then cardinal number of set power set of A, then cardinal number of power set of A is equal to 2 to the power m, which is greater than m. This 2 to the power m will always be greater than m and is equal to cardinal number of set A. This I wanted to explain. I think you are understanding. Let us see universal set in any particular context of sets. In any particular context of sets, a set U which contains all the sets, which contains all the sets as subset of U, then U is called the universal set. So, universal set is not unique. You may understand, universal set is not unique. Universal set is not unique. ये unique नहीं है. For example, you see example. Z is a set of all integers. Q is the set of rational number. Q is the set of rational number. R is the set of real number. Set of real number. It means this implies, therefore, you can say Q is universal set. Q is universal set because Z is subset of Q and R is subset of Q. It means you are understanding. I hope you will be subscribing. That's all.